Well, this is a story of a small, little tiny project. As you can see here, I've created this folder to dive deep into a hairy theme. It went pretty well. I downloaded a Mixamo guy called Ortiz.
Look at this dude.
What a cutie. Then I made a little hairy scene that looks like this. But before, I spent some time to find out how to blend animations. After Unreal's motion blending, it was quite unobvious and tricky, though it worked somehow. I've cutted a couple brims around armpits, scattered some guides, pinned the first points, growed 900 hairs with a hair gen, couple tweaks on the post-processing, and so here is the scene. Though had some troubles with the collisions, but it's okay. And then something went completely wrong, and I ended up with this piece of shit art. So, this video is not about crazy scenes or cool look depth or lighting, neither render. It's more about some stuff that I learned while doing this project and couple setups. After hair simulation, I thought it would be cool to add some funny stuff like a wrestling ring and an opponent. So I grabbed another handsome from Mixamo and made something that looks like a ring. I didn't thought about making it procedural, but I made some seamed cloth curtains instead and placed the opponent on the ring. Directly after that I thought it definitely needs some seamed wires, not to look so stupid. So I cut it to wires and sent them to vellum. Looks better. Right after that I noticed that our main hero has pretty big belly, so I immediately cut it out and threw it to vellum again. Poly reduced geo, painted a mask. For the belly used that stretch constraint and pin to target for the rest of the belly with these settings. Point deformed it back on the Mixamo topology and again, it looks a bit better. With that done, I noticed that it is a bit empty around, so it was time to make some surroundings. I was too lazy to model a chair, so I grabbed one from Sketchfab. As for their stadium model, I didn't find any suitable for my case, so I started doing my own one. Starting with the lab's super formal shapes, I made a basic shape for the first floor of an arena, some shapes for boolean, stairs and elements for each seat row. Absolutely not pretending for a modular grid and still no procedural approach yet. While trying to place stadium seats, I faced with an even scattering issue. Because each curve has its own length, grown to the top one, scattered points looked a bit weird, so the solution I found looks like this. I broke each curve into a straight and curved parts and resampled by a group with an eyeballed offset, then deleted points layered on stairs and portals and copied seats with the right orientations. Same operations for the balconies, and then I created super ugly fences. My modeling skills are definitely on the low end, I'd say, but for the low light conditions I'll take it, I'll take it. Then added walls, floor, ceiling, and ended up with something looking like this. Okay, now we have a bunch of chairs, but no one sitting there. What should we do? Right. Create a crowd simulation. I grabbed a couple more cuties from Mixamo and jumped straight into the documentation and tutorials. What I ended up with is actually funny. Instead of preparing each agent like here, I thought why I couldn't use agent layer system. And actually, it worked. I've imported the mockup man with an FBX character import node and made an agent from rig. Then I just added a layer with a character mesh and for other 4 characters too, giving each layer a name of a character. After I added all animations with an agent clip node and did an agent prep for foot locking. Here I just mapped the right bone namings and cached to disk with an agent definition cache node. In the end, what I have is only one agent with a pack of animations and with different layered meshes. By the way, Mixamo characters have different skeletons, but for some characters they are the same or similar enough. But it depends on the situation. For standard biped characters, the difference is in varying bone length, and the main one is a rig prefix. As you can see here, the amount of bones is equal and namings are the same, but the prefix differs. So if you want to retarget some enemies, you should be aware of it. Because I didn't any retargeting for my characters, some of them have little deformations, but for my situation I don't care. Well, having my agents means that I need some points to put them to. Let's do this quick. Importing the agent with an agent node, just make sure that you have the right agent name that is set in the agent definition cache node just before. Then we're grabbing agent and points into crowdsource, and we're ready for the simulation. As for the sim, it's actually quite simple. Just sourcing two crowd states for sitting and standing animations, a crowd trigger set to animation clip loops, and a crowd transition from sit to stand. The crucial part, I guess, is setting the right namings in the state and transition nodes. Compared to crowd sim alone, with a bunch of geometry merged, my FPS difference is hectic. So I needed to cut my geo somehow. Camera first method comes in quite handy. I made one based on the video by Short and Sweet 3D and added couple my own tweaks. It works without any volume, just little bit of wax and wops. If you want to test my version, leave a comment, I'll upload it somewhere. Okay, what's next? Let's put something into the stage context and maybe we'll see something mandatory things are missing. Yeah, definitely we need some jury tables and crowd themed agents. Okay, what else? Maybe a fire machine at the entrance? Of course, give me two. I made some decorative meshes to get fire from, also a couple meshes for fire source, adding a bit of velocity and randomizing initial state of velocity vectors. Straight into the pop simulation, adding some steer separate, and our source is ready. With these PyResolver settings, simulation looks like this. We have this type of machine in the end. Also some offsetting for the second one. With the fire in place, I guess we need more things in the frame, so why not to add a confetti machine, or four for example. Starting with the cannons, I place them on a ring. As for confetti, it is just a 3x10 grid, bent in different directions. In for each loop, based on the connectivity, I added some normals and UVs. Then I separated each one and used mobs instancer to randomly place confetti geo on the points, which we are getting from the dope particle simulations. For the cannons I used small mass and pop flock, force and drag forces to have a needed look. I wanted to achieve a bit more randomness, but flocking works like a firework, so not this time. Pop spin is used to set random rotations while falling. They are falling like snowflakes a bit. And I'm also using collision detection and pop wrangle, reading a path hit attribute to stop confetti spinning when it is reaching the ground. So those green ones are that already stopped spinning. I made 3 of simulations, 2 are for the ring cannons and 1 for the falling from ceiling confettis. And also camera frustum helped here too. Okay, let's return to the stage. What else? What else? Stadium lights that are following our main hero? Sounds cool, but Solaris is using instances and there is quite strange situation with the animating inside Solaris. And for example, look at constraint doesn't work on lights because we don't have any keyframes imported from shopping part node. It works only if animation happens inside of Solaris, but follow path constraint, for example, works well, so a little life hack was invented. I created a simple cube and attached it to our hero with a path constraint. So now we have animated object inside Solaris. Then I'm just feeding it to look at constraint and finally pruning the cube. Easy! Looking at our cool follow lights, I guess we need some animated ring lights. But for that we need to model some scaffolding or firms first. Yep, it's finally something procedural in this project. I'm skipping the part where I modeled spare parts for this system, because if you are a modeler, bleeding from ice isn't cool thing, trust me. So I have some spare parts, let's combine them to something procedural. Let's start with a grid and corner pieces grouping corner points by a valence of 2. Then let's add some central 4-way connectors grouping by a valence of 4. And then border connectors grouping, you guessed, by a valence of 3. Then I'm grouping and getting centroids for the border curves, the same operations for the central parts, and it's here. And here I am adding some points for the actual lights scattering. All in all, HDA has only 2 sliders, but maybe I'll implement another logic later. As for now, it's time to make some animated lights. I downloaded a nice staged light model, separated, named, and UV'd its parts, and extracted centroids for the rotating parts. In these 3 transforms, I'm getting the centroid's position and moving a pivot to it, and applying chops noise with the restricted rotation angles. After that, just copying 2 points from the procedural scaffold setup based on the calculated orientation vector. In this loop I'm just creating a vector for the spotlight to be oriented in the stage. And finally, in the stage I'm setting an instancer where I have imported points and orientation vectors. Also I am randomizing color attribute, cause lights in the stage context can use it. For the flashlights I used the same instancing technique. The difference is only that light type is geometry light, where I used a simple box and an emissive color. Okay, there are some materials and lights, but it's not serious, so what else? I almost forgot about a camera. I made a camera rig based on a circle that follows an object. Definitely would improve and expand the functionality of this HDA in the future. And it looks like we're in the end of this adventure. Thank you for watching, and maybe something will be sometime in the near future, or maybe not. Good luck. See ya.